Canada is home to several nuclear power plants located in Ontario, Quebec, and New Brunswick. This video will help you learn more about the safety systems of these plants, which are operated and maintained following strict rules established by Canada's nuclear regulator. We are the Canadian Nuclear Safety Commission. But first, to get a better idea of how these safety systems fit in, let's look at how a nuclear power plant works. All nuclear power plants in Canada use the CANDO design, a safe, reliable reactor technology. CANDO reactors produce electricity by splitting atoms of natural uranium to create heat. The heat is then used to make steam to power the turbines and generators, which produce electricity. After the uranium or nuclear fuel has been used in the reactor, it is removed and stored securely in a pool for a period of 6 to 10 years. The water in the pool continues to cool the fuel and provides shielding against radiation. All of Canada's fuel pools are built in ground, in separate buildings at the nuclear power plant, and are designed to withstand earthquakes. Nuclear power plants have multiple safety systems to ensure three basic functions: controlling the reactor, cooling the fuel, and containing radiation. These systems are maintained and inspected regularly and upgraded when necessary to ensure plants meet or exceed safety standards. We'll briefly explain the main safety systems for each of these three functions. First, let's look at controlling the reactor. When the reactor is operating, the power level is controlled by adjuster rods and by varying the water level in vertical cylinders. Sensitive detectors constantly monitor different aspects like temperature, pressure, and reactor power level. When needed, CANDO reactors can safely and automatically shut down within seconds. Nuclear reactors in Canada have two independent, fast-acting, and equally effective shutdown systems. The first shutdown system is made up of rods that drop automatically and stop the nuclear reaction if something irregular is detected. The second system injects a liquid or poison inside the reactor to immediately stop the nuclear reaction. Both systems work without power or operator intervention. However, they can also be manually activated. These systems are regularly and safely tested. Once a CANDO reactor is shut down, it will stay this way until restarted by the operators in the control room. There is absolutely no possibility of the reactor accidentally restarting on its own after it's shut down. The reactor must be manually restarted. Following shutdown, the amount of energy produced by the reactor decreases rapidly. The nuclear fuel will, however, continue to produce some heat and must be cooled. That heat, called decay heat, represents a small fraction of the heat produced during normal operation. Now let's look at the second basic function, cooling the fuel. Because of decay heat, nuclear fuel requires continuous cooling, whether or not the reactor is operating. Fuel cooling involves three main systems: the heat transport system, the steam system, and the condenser cooling system. Let's take a closer look at each of these. The heat transport system brings the heat produced by the reactor to the steam generators. This system is made up of very robust pipes filled with heavy water, a rare type of water found in nature. Pipes and other components are maintained and inspected regularly and replaced if needed. Inspections include measuring pipe wear and tear and identifying any microscopic cracks or changes well before they become a problem. The second system, the steam system, uses normal water. The heat from the reactor turns this water into steam to run the turbines and generators. That steam is then cooled and condensed using a third system that pumps in cold water from a body of water such as a lake or reservoir. This is called the condenser cooling system. Like other components, the steam and condenser cooling systems are regularly inspected. A simpler cooling system is used when the reactor is shut down for an extended period, for example during a planned outage. It requires little power to function and is connected directly to the heat transport system. In the unlikely event of a loss of heavy water, which could, for example, be caused by a pipe break, emergency injection systems would ensure water continues to circulate over the fuel to cool it. Emergency injection systems would work with pressurized tanks of nitrogen or pumps. All plants have 2 or 3 injection systems. A collection basin located in the basement of the reactor building would recover the water and pump it back into the reactor until repairs are made. Electricity is needed for all cooling systems to operate normally. Nuclear power plants in Canada are equipped with multiple sources of backup power if they get disconnected from the grid. Sources of backup power include on-site power, that is, the power produced by the plant itself. In addition, at least 2 or 3 standby power generators, 2 or 3 emergency power generators, and emergency batteries are available. You can learn more by watching our video that describes what would happen in the very unlikely event of a total station blackout. This video is available on YouTube. Now, let's look at the third basic function, containing radiation. Nuclear reactors are built with multiple barriers to safely contain radiation. At the heart of all CANDU reactors are hardened ceramic pellets made of natural uranium. These pellets contain the radiation. They form the first layer of containment. The pellets are contained in rods, which form the second layer of containment. CANDU fuel rods are made of zirc alloy, a metal alloy extremely resistant to heat and corrosion. The rods are then loaded into pressure tubes, which are part of the heat transport system. This is the third layer of containment. The pressure tubes are contained inside a metal tank called the calandria, which itself is contained inside a thick vault made of reinforced concrete. The fourth layer of containment is the building that houses and protects the reactor. The walls of the reactor building are made of at least 1 meter of reinforced concrete. The reactor building is surrounded by a 1-kilometer exclusion or buffer zone. All plants are equipped with high-efficiency filters. These filters are used as part of the operation to minimize radioactive releases from nuclear power plants. These releases occur as part of normal activities like system maintenance. Filtering systems are regularly inspected, and power plant operators must, by law, report all radioactive releases into the environment. In the unlikely event of an accident, safety systems are in place to protect the containment from internal pressure due to steam releases inside the reactor building. In a single-unit station, internal pressure would be lowered by spraying water from a dousing tank. In a multi-unit station, pressure would be lowered by releasing steam and hot gases from the reactor building to the vacuum building. The vacuum building is a structure specifically designed to quickly and safely lower pressure inside the reactor building. This building also has a dousing system to control pressure. The vacuum and dousing systems work without power and are tested periodically under the supervision of inspectors of the Canadian Nuclear Safety Commission. Let's have a closer look at the Canadian Nuclear Safety Commission. Our job is to establish strict rules for all nuclear activities and to make sure they are implemented to protect people and the environment. The rules include stringent requirements for the design, inspection, testing, and maintenance of all important safety systems at nuclear power plants. Nuclear safety is our business. We have a team of professional staff, including inspectors permanently stationed at each of Canada's nuclear power plants. These inspectors are our ears and eyes on site. They inspect nuclear facilities throughout their life to confirm that aging equipment is functioning as originally designed. If an operator is not following the rules, we take immediate action to correct the situation. As part of our work, we also make sure information about the operation of these facilities is publicly available. For example, every year, we publish a detailed report about the safety performance of Canada's nuclear power plants. We also closely collaborate with our international counterparts and the International Atomic Energy Agency, an agency of the United Nations. We are committed to continuous improvement and applying the best safety standards to our Canadian facilities. Close to half of our technical staff have doctorate or master's degrees in fields such as engineering, chemistry, physics, and environmental and health sciences. Members of our staff are available day or night to provide support and clear communications in the unlikely event of a nuclear emergency. Their work and dedication is part of the reason Canada's nuclear power plants are among the safest in the world.